Hello everyone, this is a new video related to chain rule. In the last video of chain rule, I discussed with you the basic idea of chain rule of indifferentiability as well as the Leibniz notation of it, and I discussed few of the examples and the two methods how to solve the questions related to chain rule. In the new video, I'll discuss some more complicated examples with you. So just pay attention and let's start our lesson. So the example that I considered here is find the derivative of sec tan root x. Okay. So our function is sec tan root x. So basically our y function is a composition of three functions, sec, tan as well as root x. Okay. So how are we going to solve it? In the last video I discussed two methods and I told you that the second method is very easy approach and generally we use the second method to solve the questions. So I am going to use that method only to solve this question. So what is that? We want to differentiate y with respect to x. So dy upon dx equals to d over dx of y. In place of y we are going to write this function. Okay. Now this function is sec tan root x. So you just forget about tan root x, you just treat it as sec x and just tell me that what is the differentiation of sec x. So in 11th standard you read all the formulas. So the differentiation of sec x is sec x tan x. Okay. So now just remember the formula and use it. It means the formula is sec x and tan x. Let me write it clearly. The formula is sec x tan x. Okay. Now if you see, we considered this part as x and the differentiation is this. Now in place of x what we will write? Tan root x. So this will become sec tan root x and then tan root x. This is what we are going to write. Okay. After that, in place of x this was there. It means this is what that was not the part of our standard function sec x. So we are again going to differentiate this tan root x. So first of all you write this one whatever we have written here and then you write d over dx of tan root x. Okay. Now just forget about this root x and treat it as tan x. So what is the formula d over dx of tan x? That again you have studied in 11th standard. So that is sec square x. So what we will do? We are going to write sec square x in place of x this root x. Okay. Now again because we are imagining x here and what is exactly that is root x. So we will differentiate it again. So d over dx of root x. Okay. So just see it in the next slide. This is what just pay attention. This is what we got in the first line and then we differentiate tan root x, we will get sec square root x and d over dx of root x. D over dx of root x is nothing but x to power half. That is d over dx of x to power n, and x to power n, what is the formula? N x to power n minus 1. So this will become half x to power 1 half minus 1, that is minus half. So this is what we will get as our result. So basically what are we doing? Just pay attention and listen. Our question was sec, then tan and then root x. So first of all we have considered sec and this portion as x and we have differentiated as sec x tan x. Okay. Now sec x, what was there at place of x? That is tan root x. So we are going to replace it. Now tan root x was not the part of the standard function sec x. So we will redifferentiate tan root x. Okay. And then tan root x formula is sec square root x. But in place of x what is written here? Root x. So we will again differentiate root x. Okay. So like that, that's why it is called chain rule. It means first of all you solve it as a standard function, and whatever is not the part of the standard function, you redifferentiate. And again, if the same problem is occurring, then again you redifferentiate it. This is how we solve it. It's very easy. Keep your mind just balanced and solve it. Okay. So now you see the next example. Next example, these examples are the part of your exercise only 5.2. So you can refer your NCERT book also. So what is there? Show that fx equals to mod x minus 1 is not differentiable at x equals to 1. Whenever you want to show that the function is not differentiable at a certain point, you just show that left hand derivative is not equivalent to right hand derivative. Again, I discussed this in the definition of differentiability. Okay, so this is what you are going to consider. So what was, if you remember the definition, what was that? Limit x tends to c. Okay, fx minus fc upon x minus c. But they have said x equals to 1. It means in place of c we are going to use 1. Okay, that you remember. Now left hand, for left hand we are going to write 1 minus. Let me change the color. That is 1 minus. Okay, so 1 minus means 1 minus h. We are going to replace it with limit h tends to 0. So this will become 1 minus h, and in place of c 1. So this is f1, and this become minus h. Why minus h? Because x is replaced with 1 minus h and then minus 1. 1 and 1 will be cancelled. So what is left? Minus h. Okay. Now your function is fx equals to mod of x minus 1. Mod of x minus 1. So just pay attention. Mod function you know very well, for mod x minus 1. So this function can be defined in two ways. For x greater than equal to 1 and for x less than 1. So here the case is x less than 1. So for x less than 1, this function will become h. Okay, this function will become h. So h upon minus h, that will give you minus 1. How is it happening? That you can see. Mod x minus 1 can be defined as x minus 1 for x greater than equal to 1 and minus x plus 1 for x less than 1. Okay, now this condition is x less than 1. So minus x plus 1 and minus x, in place of x what is written here? 1 minus h. So minus 1 plus h and then plus 1. So 1 and 1 will be cancelled. What is left here? H. And if you are going to put 1 here, so 1 minus 1 will become 0. So this will become 0. So here it will be h only. So h upon minus h, h and h will be cancelled. So your result will be minus 1. Is it clear? Okay. Now you see the right hand derivative. In right hand derivative, the same thing, nothing is extra, 1 plus. So here it will be 1 plus h. For 1 plus h, what it will be? It will be simply x minus 1. So in place of x, 1 plus h minus 1. 1 and 1 will be cancelled, h. So h, and again this portion will become 0. So h upon h, that will give you 1. It means your left hand derivative is minus 1 and your right hand derivative is plus 1. So left hand derivative is not equivalent to right hand derivative. Therefore, f is not differentiable at 1. So very easy approach. Whenever you want to show that the function is not differentiable at a particular point, then you just show that the function left hand derivative is not equivalent to right hand derivative. That is very easy question of limit, and that you can solve very easily. So again, I ask you to solve this question one more time. Solve your exercise 5.2 as your assignment. Just do all the question, and if you have any query, you can ask me. Thank you so very much.